Okay, second half of chapter 7 is transitioning into matrices. The first section here, 7.4, is just introducing the size of a matrix, which is called the order of a matrix, and just introducing what we're going to be doing with them throughout the rest of the chapter. So a matrix is numbers that are arranged in a rectangular array. So there are m rows, rows are horizontal, and n columns, and columns are vertical. So the order of a matrix is the number of rows by the number of columns. So to determine the order of a matrix, we're looking at, okay, how many rows does it have and how many columns does it have? Letter A just has one of each, so this is a 1 by 1 matrix. So again, we're starting horizontal. Letter B, we're looking, there's one horizontal row and there are 4 vertical columns, 4 numbers across. So that's the number of columns. So this is a 1 by 4. Letter C has 2 horizontal rows and 2 vertical columns. So it's a 2 by 2. And letter D has 3 horizontal rows by 2 vertical columns. So it is a 3 by 2. Okay, so the relationship that we can make between matrices and linear equations, systems of linear equations, is we can take a system and take all of the coefficients off of it, and that's called the coefficient matrix. So each of the numbers in the matrix is going to represent a coefficient in a corresponding set of linear equations. And then there's an augmented matrix, which also has the constants in the system. So if we start with this system of equations in 3 variables, the augmented matrix, which has these 3 vertical dots to indicate the spot where the equal sign would be, and the number to its right is going to be the constant from the system, which is almost exactly the same as the coefficient matrix, except for it just doesn't have the dots and the numbers to the right, but just the coefficients. So notice in the third equation, we're missing the y variable, which is why there's a z or a 0 in that y spot, in that second spot in the third row. So if I have this system of equations, let's write the augmented matrix for it. Notice that some equations do have z, so this is going to be a 3 variable system of equations. So the top is 1, 3, and then I don't see the z there, so it's going to be the 0. And then I put those dots with the constant. Second one doesn't have an x, so it's going to be 0, -1, 4, dots, -2. And then the last one, 1, 0, -5, dots, 0. That's it. Okay, so now we're going to introduce elementary row operations. That's where we take a matrix and we do something to it. It some of the things we're going to be asked to do would be to interchange 2 rows, so literally just switch the rows, multiply a row by a non-zero constant, or add a multiple of a row to another row. So what that looks like, here's a matrix on the left side here. Let's interchange the first and second row. So the second row is now my first row. -1, 2, 0, 3. The first row became my second row. 0, 1, 3, 4, and we did not touch the bottom, so that still stays as the bottom. Letter B, multiply the first row of the original matrix by 1/2. So the only thing that's changing is the first row is getting multiplied by 1/2. 1, -2, 3, -1. The rest of the matrix stays the same. 5, -2, 1, 2. Now what if I need to add -2, so the way I'm going to write this notationally, -2 times the first row to the third row. So that's actually going to be the third row answer, this right here. We're going to take the first 2 rows stay the same. I'm just going to rewrite those so we don't forget to do that. The only one that's changing is the third row, and we're going to take -2 of whatever number's in the first row and add it to the corresponding number in the third row. So for example, -2 times 1, which is -2, add that to 2, and we're going to get 0. -2 times 2 plus 1 in the corresponding same location is going to be -3. -2 times -4 plus 5 is 13. And -2 times 3 plus -2 is -8. So even if I'm using row 1, that's not changing. Row 1 still stays the same. I'm just using row 1 to change row 3. Okay, now there's a special form of a matrix called row echelon form. There's also reduced row echelon form. Row echelon, a couple um, conditions have to apply for it to be considered row echelon. The first one is if there are any rows that are entire zeros, that has to be at the bottom of the matrix. The second condition is that for each row that's not entirely zeros, the first non-zero entry coming from the left has to be a 1. That's called the leading 1. For two rows in a row that are not all zeros, the leading 1 is in the higher row is further to the left than the leading 1 in the lower row. So you would expect this kind of step from, if you're looking from the top to the bottom, those 1s would move down to the right as you move down. And then the last one, reduced row echelon form, means that the leading 1s of all of the rows above and below are zeros. So first, let's go through and talk about what either makes these or doesn't make these row echelon form, and then we can decide from there if it's reduced row echelon form. So we're looking for that kind of step from top to bottom, left to right, that those 1s are getting moved down, which they are. There's no non-zero, there's no rows that are all zeros, so we don't have to worry about that piece, but the 1s are kind of moving down in that step, which makes this row echelon. And then once we know that it is row echelon, we can decide whether it's reduced row echelon. And that would be if all of our leading 1s had zeros above and below. So because of this 2 above that leading 1, this is not reduced row echelon form. Letter B, it has a row that's consisting of all zeros, but because this is not on the bottom, it is not row echelon form. I'm just going to start doing RE for row echelon, not row echelon. Okay, letter C. I do see that step motion. The top left is a 1, and then the one next leading 1 does move down in that step. So this is row echelon. But because our leading 1s do not have zeros above or below, this is not reduced. Letter D does have a row of all zeros, but since it's at the bottom, we can continue. The leading 1s do move down in that stepping motion from left to right. So this is row echelon form, and then I look at the leading 1s and see that there are zeros above and below. So this is also reduced row echelon form. Letter E has this 2 leading that row, which means this is not reduced, not row echelon or reduced row echelon. And then letter F does have leading 1s. The bottom row is all zeros, which is okay. The leading 1s are moving down in that step motion that we like, so it is row echelon. And because all the leading 1s have zeros above and below, this is also reduced row echelon. And that was it for introducing matrices in section 7.4.